Okay, we're on page 374, binomial radical expressions. Let's look at example 1. 5 times the cube root of x minus 3 times the cube root of x. You're going to treat these radicals like variables. As long as they are identical, you can add and subtract their coefficients. Okay? As long as the radical part is identical, you can add and subtract the coefficients. So I have 5 times the cube root of x minus 3 times the cube root of x. So it's like having 5 and taking 3 away, and what are we left with? 2, and the radical part just tags along, 2 cube roots of x.
So you can't subtract stuff under the thing you got in?
No, you can't subtract and add under the radical. You can only do, if their whole radical is the same, it's kind of like being a variable. The next one says 4 times the square root of 2 plus 5 times the square root of 3. Now, in order for me to combine these, the radical parts have to be identical. They have to be to the same index, or to the same, you have to be taking the very same root. The stuff that's under the radical has to be the same. Is that the situation we have with this one? No. You can't do anything to this problem, okay? Cannot be combined. Next, 2 times the square root of 7 plus 3 times the square root of 7. Dalton? What's that? 5 times the square root of 7. Don't write the square root of 14 there. That's not what that is. Y'all with me? Y'all paying attention? It's not 14. Can't add those parts together. The next one is 7 times the fourth root of 5 minus 2 times the cube root of 5. What do y'all think about this one? Cannot be combined. The indexes were different. One was a fourth root and one was a third root. And they have to be the same. 4 times the square root of xy plus 5 times the square root of xy. Nine times the square root of xy. So we can add and subtract radicals as long as they're the same exact radical part. Okay, next example. Example 2. 6 times the square root of 18 plus 4 times the square root of 8 minus 3 times the square root of 72. Do I have everybody's attention? Simplify and then see if there's anything you can combine. Right now, none of those radicals are the same, so you can't combine them. But maybe if you simplify, something will become a like term. So what about the square root of 18? What can you do to the square root of 18 to simplify it? That's like having the square root of 9 and the square root of 2, right? What's the square root of 9? So this is 18 square root of 2. Okay. What about the next one? What's your suggestion? Four times the square root of 4 times the square root of 2. It's going to be 4 times 2 times the square root of 2. 8 square root of 2. And the last one, 72. What goes into 72? 36. Okay, so now that I have simplified, all 3 of them are like terms. So start with the first 2. What's 18 plus 8? 26. Minus 18 square root of 2 is back to 8. Any questions there? Sometimes when you have these problems, two of them will become like terms and the other one will simplify, but you may be left with something like a 3 under the radical. So you may end up at the bottom with two things instead of just one. So they may not always all combine, and then they may not combine at all. They have to have the same radical part to combine. Yes?
Why couldn't you do like on 618, why couldn't you just do 6 and square root of 9? Why do you have 16?
Okay. 18 is acquired by multiplying 9 and 2, right? I can take the square root of 9, it's 3. But I can't take the square root of 2.
So why couldn't you just like put 9 and not the 2? If the square root of 18 is 9.
But the square root of 18 is not 9.
Oh, okay.
The square root of 81 is 9. If I had the square root of 81 on my paper, then I could just write 9 and I'd be done with it. I wouldn't have to write another thing down. But 18, its answer is not 9. It's just factored into those two numbers so that you can get part of its answer. Okay?
So under the square root and 2, 2, and 3, you just put cannot be combined?
You put the twos together and you just... Okay. Now, let's look at example 3.
Will we ever have problems with 2 that will do that?
Yeah. Okay, now we are multiplying these things together and we're going to use FOIL. Write this down. You know how to add them, you know how to multiply them, you know how to subtract them, know how to combine them. So now we can do FOIL. Since we got all those skills acquired, now we can do FOIL. So here we go. First times first is 6. Outside times outside. You're going to multiply the parts that are the coefficients, whole numbers, whatever you want to call them. You're going to multiply the 3 and the 4, and you're going to get 12. And you're going to treat that square root of 5 almost like you would treat a variable. So we did first times first and outside times outside. Now inside times inside. What is 2 square roots of 5 times 2? 4 square roots of 5. And then last times last. Now, here you go. Y'all pay attention to this. I'm going to multiply 2 times 4, and I'm going to get 8. And since I have two radicals, I'm going to multiply the stuff under the radical and get the square root of 25. Okay?
Wait, can you repeat why you did that?
Since I'm multiplying a radical by a radical, the numbers under the radical can be multiplied together. See, here I multiplied this one that did not have a radical by this one that did. So the radical part didn't have anything to multiply by, so it just tagged along. But when I multiplied these, since I had coefficients outside, multiply them together, and when you multiply two things under the radical, you go ahead and multiply the numbers that are under the radical. Okay? You follow me? Okay. So these can be added together, and you get 16 square roots of 5. This one actually has an answer. What's the answer to the square root of 25? And when you multiply it by 8, what do you get? 40. And then,
46.
there you go.
So you don't further combine those?
Nope, that's as far as it'll go. This one doesn't have a radical. This one does. Can't be put together anymore. Okay, let's do the next one. Square root of 2 minus the square root of 3 squared. Write this down and listen. Do not say, oh, that's easy. Just square them. 2 minus 3, -1. Don't do that. That's not how that works. Okay? They want you to multiply the square root of 2 minus the square root of 3 times the square root of 2 minus the square root of 3. Now remember what I told you. If you're multiplying two things together and they're both radicals, multiply the numbers under the radical, which is all we have in this problem. I don't have anything on the outside. So here I go. Square root of 2 times the square root of 2. What's that going to give me, y'all? Square root of 4. Square root of 2 times the negative square root of 3. What happens when you multiply 2 times 3? You get 6. Outside, first times first, outside. I did outside times outside. Inside times inside.
Plus 6.
It's minus square root of 6. And then last times last. Plus the square root of 9. Okay. Here we go. What's the answer to the square root of 4? 2. Now this is minus 1 square root of 6 and minus another square root of 6. So together that's going to make minus 2 square roots of 6. Everybody knows why that works that way, right? It's not 12.
So if you had like, square root of 2 times square root of 2, then
Be 0. What's the answer to the square root of 9? 3. Combine your 2 and 3. Okay, we got that? Can we do that? Example 5. 2 plus the square root of 3 times 2 minus the square root of 3. Okay, are you listening? Are you paying attention? First times first. What's 2 times 2? 4. 2 times the negative square root of 3. What's that? Inside times inside. Plus 2 square roots of 3. And last times last. Minus the square root of 9. Okay, what happens to these in the middle? They cancel out. So they're completely gone. They make 0. They add up to 0. So this is 4 minus, which is 1. Why did they go away in the middle? Why did they add up to be 0 in the middle?
because one was negative and the other one was positive.
One was negative and one was positive. What kind of situation gives me that scenario? Okay, she said these have to be the exact same numbers, just different signs. There's a name for that, and it's called conjugates. Y'all conjugate verbs? You ever heard of that? I don't even know if it's, I have no idea if it's the same thing, because I don't remember what conjugating verbs is. But these are called conjugates. Where might you need this skill? I mean, the nice thing about it is the radicals are completely gone, right? Do you have any other square roots to deal with? No. So this is just a little tool in your toolbox of ways to make radicals disappear. Where are places we don't let radicals stay? Bottom of a fraction. So that leads me to this problem. 3 plus the square root of 5 over 1 minus the square root of 5. I can't have that radical in the bottom. What we rely on, the first thing that comes to our mind, because this was the first thing we learned, is, ooh, I need to multiply by the square root of 5. If you do that, you eliminate this part, but you stick a square root of 5 on the 1 and you got something else to worry about. So when you have a problem that looks like this, you still multiply by 1, but use the conjugate. So what should this say? And you have to do FOIL. Okay, you have to do FOIL. You have to do it twice. 1 times 1 is 1. 1 times the square root of 5 is the square root of 5. 1 times negative square root of 5 is negative square root of 5. And then the last times last is minus the square root of 25. So do the ones in the bottom go away that I wanted to. Let's see. I get 1. That makes 0, so they're gone. Minus 5. Well, that's negative 4. So I have successfully eliminated the radicals from the denominator. I did that by multiplying by the conjugate. Multiply in the top and simplify. 3 times 1 is 3. 3 times the square root of 5 is 3 square roots of 5. Plus 1 square root of 5. Plus the square root of 25. So we're going to have 3. What's the answer to the square root of 25? 5. Can I go ahead and write 8 right down here? Are y'all okay with that? And then these are going to combine and give me 4. And then my answer is here. Okay, so I finally got to the last part, and I've written my answer, and I don't have a radical on the bottom. There's one more thing you have to check. You have to check all the whole numbers, all the numbers outside of the radical. You've got to check those here, here, and here. If all 3 locations have something you can simplify by, you need to simplify. If it's just in 2 locations, you can't do it. But if it's in all 3, then you need to do it. So what goes into all 3 of those? Anything else? 4. 4 goes in here 2 times. 4 goes in here 1 time. 4 goes in here 1 time. So that's my answer. Now you may see it written that negative may be applied to the top, and it'll have to be applied to both parts. Negative 2 minus 1 square root of 5. Okay? Alright, let me give you some problems to work. I want you to do 2 through 26 even. Page 376. Today is Thursday. We'll do more on Friday, but for today that's what we're